Welcome to this video about tectonic plate boundaries. And as you can see on this map, there are the world's lithosphere is split into different plates, and these plates have edges, and these edges contact with the edges of the plate next to them. And if the edges are moving apart, it is called a divergent plate boundary. If they are coming together, it is a convergent plate boundary, and if they are slip-sliding with respect to each other, it is a transform plate boundary. So let's have a look at the features of each of these boundaries. So divergent boundaries, those are the ones that are pulling apart. They aren't found everywhere, but you'll notice on this map that most of those divergent boundaries are under oceans. So we have things like the Pacific Antarctic ridge, the famous Mid-Atlantic ridge, that's where the deepest parts of the ocean are. And there is one little spot here where the Mid-Atlantic ridge is visible on land, and that's through the middle of Iceland. So we can have a look at the different features. So how do plate boundaries pull apart from each other? So you can see on this little image here, this moving image, that the center of the Earth, the core, is hot, and that is heating up the liquid rock, the mantle, and that causes a convection current up through the center here of this hot spot, and that hot magma is rising, and as it reaches the crust, it starts to cool, and it becomes kind of sticky to the underside of the crust and pulls the crust sideways. So we're pulling apart the plate sideways through convection currents in the mantle. So on this still image, you can see the convection currents drawn as circles. We've got hot magma rising and moving and cooling and sinking. And whilst it does that, it drags oceanic crust to the side. And that's happening in two circles on either side. So we have hot magma reaching the surface underneath the oceans, and it forms new solid rock, so igneous rock, at a feature, a landform called a ridge. So this is the newest Earth on our planet being formed, the newest rock. And if you see sort of stages of how we would form a new ocean floor, at first you would get a rift valley where new rock has formed, and the continental plates are moving side to side, away, diverging from each other. And then as that widens, oceans can come in and fill in the gap, and we're getting new rock still forming in the center here, and the continents are still drifting apart from each other. And eventually you'll get formations like the mid-ocean ridge, where you get a very low-level mountain range, very low-level volcanic activity, but brand new igneous rock forming as these continents move apart. So sorts of features we see underneath the ocean, we see hydrothermal vents. So these are hot vents or outgassing from this new molten rock that's coming to the surface, and whole sort of life forms form deep under the ocean at these hydrothermal vents. And we also get on the surface, I said it came up, you could see valleys in places like Iceland, so you've got drifting apart of the plate at the Earth's surface, and you get things called rift valleys. There's also a rift valley across part of Africa too. So divergent boundary features, so where tectonic plates move apart, mid-ocean ridges, low-level mountain ranges, site of high level of hydrothermal vents, rift valleys forming on land, and igneous rock called basalt being formed. The next type of boundary is convergent. This is where plates come together. We could have oceanic plate coming together with oceanic plate. We could have oceanic plate coming together with a continental plate, and we could have two continental plates colliding. And we get slightly different features forming when these come together. Let's have a look at how that works. We've seen convection currents in the mantle forming our divergent plates, but at the other end of the plate is being pushed down and recycled and melted into rock again. And that is the bit where they're coming together or converging. So we're going to concentrate on that area. Here's a nice little animation of it happening. You'll notice a few things. Maybe you're noticing that as this plate is moving and subducting, being pushed underneath another plate, it's a bit jolty, and that means there are earthquakes happening. The other thing you might notice is that as the plate dives deep into the hot mantle, it is starting to melt. Molten rock is less dense than solid rock, so it pushes its way up through and erupts on the surface as molten lava or volcanoes. So the sorts of features we're going to see are earthquakes, mountain building and volcanoes at convergent boundaries. So here is where oceanic plate is meeting continental plate. So in comes the oceanic plate here, and it dives deep, it subducts below the continental plate, which is here. We've got rising molten rock, we've got ridging up of the continental plate as the oceanic plate pushes underneath it, so mountain forming, and we've got a large trench forming where they meet and it pushes down. You get a really deep trench at the boundary where it's going down. The other thing that can happen is we can get little arcs of islands forming. So there's a convergent boundary here, and we've got little arcs of islands forming where the volcanoes are erupting. We can also see very deep trenches. So just off the coast of Australia and New Zealand, we have the Tongan Trench. That's a very deep part of the ocean, over 10,000 meters deep. And we also get mountain ranges where continent meets continent, and you get the famous Himalayan mountains, as well as the Alps in Europe. They're all formed by plates coming together and pushing up in the middle. Trenches and volcanoes, I said you could get volcanoes. The Ring of Fire, which is the ring of volcanoes which occurs all around the edge of the Pacific Ocean. So there's the Tongan Trench, and all the way around past Japan. That's the islands that I was mentioning earlier near Alaska, and all the way down the side of the Americas. That is called the Ring of Fire. There's lots and lots of earthquakes and volcanoes happening in that area. This is a map showing the trenches and the volcanoes, and this map shows the earthquakes. And you'll notice a very similar pattern. Earthquakes happen where convergent boundaries come together. So these are our features that we've talked about, and you can note those down. The last of our boundaries is a transform boundary. This one is a little bit less exciting because we only really get earthquakes. This is where boundaries move side to side. Little image here showing the two plates slipping past each other. And the kind of land features we get look like this. So the San Andreas Fault, you've got a plate on the left and a plate on the right, and they are slowly moving past each other. The thing is, they don't move smoothly. So they'll push and push and push and stretch, and then suddenly they will jump. And you can see here this fence, which was once a complete line, has now got a 2.5 meter gap because there was a sudden jump and one plate moved compared to the other 2.5 meters. So we get them sliding past each other, and the friction makes those jumps very jerky, and those sudden bursts of energy released are known as earthquakes. So that's our 3 different types of boundary, with lots of different landforms and lots of different features that you can look out for so you can characterize and find them on a map or when you see landforms in nature.